Hello everybody, and welcome back to the SolidCAM Introductory Series. In this video, we're going to cover facing operations. Now, when we say facemill operations, we're not actually referring to the type of tool you might be using, facemill, shell mill. We're actually talking more about the act of physically facing the part, removing all of the material from the top surface of the part. And that distinction will make a little more sense when we get through how these toolpaths are actually generated and what the toolpath is looking at. To add your facing operation, there's a couple of ways you can do that. You can go up to the SolidCAM Operations tab right here, click on 2.5D, and click on Face. You can also click directly on the 2.5D tab as well, and Face is right here. Or you can right-click on Setup, go down to Add Milling Operation, and Face. Like with all of our operations, we're just going to walk through this tree right here from top to bottom, and we'll go through each step. The first thing we have to do is define our geometry, and there's two main ways we can do this for a facing operation. The first is going to be by stock-based boundary, and the second is going to be by a part-based boundary. Now, a stock-based boundary is probably going to be the easiest to set up and one of the more powerful ways, but it does require you to have your stock defined within the CAM project. Now, if you don't have your stock defined within the CAM project, you can simply use the part-based boundary. So we'll start with that one. For the part-based boundary, the first thing we have to do is actually select our geometry. So we'll click on New. And we have a couple different ways to define our geometry. The first is going to be model-based. In this case, we're going to be selecting just whatever target our part is. So we can click on Define, and we can click anywhere on our physical part. It doesn't matter where because it's going to be the entire model we're looking at. We'll see it populate in the side here. Click the green check mark. And because this is a facing operation in a simple 3-axis machine, all that SolidCAM is going to do is look top down on the part and define a bounding box around that part that is going to be where our facing operation has to take place. Now you can see that by default we're placing a bounding box around the entire part. That's what this base geometry option section right here is for. If we wanted to, though, we could change this to silhouette and get a more exact outline of our part. Now, for this part, it's a relatively rectangular part. It wouldn't make too much of a difference, but if you had some really weird outjuttings or oblong parts, it could be useful to not do a bunch of air cutting and cut only where the actual silhouette of the part actually is. Now, our next option for selecting geometry is with the faces option. So instead of selecting the entire part, we're going to select a particular face that we'd like to focus on. Now, in this case, we don't have a good example of how we'd use that here, but let's pretend that this feature right here was actually a boss that was well above the top of the part. This could be useful for selecting just an island on a part that you need to focus on instead. So if we go to Define, and then we select just that face, we'll see it populate down here, hit the green check mark, and SolidCAM has pulled the outline of just that particular region. Now, like before, we have the option of putting a bounding box around that entire section, or doing a more precise silhouette of the exact contours of that feature. And lastly, our most controlled option is going to be Profile. That's where we can define the exact profile, the exact contours that we'd like to use in order to define our geometry. Now, this contour selection dialog box is going to be virtually the same throughout SolidCAM, so we're going to cover it in more depth in our pocket and profile operations. So for now, just know that this is how we're going to select our chains that define our boundary. So in this case, let's just use the top of the part. SolidCAM has correctly assumed we want to do constant Z and grab the whole perimeter of the part, so we'll say yes. And we'll hit the green check mark to lock in that chain. And you see that we've generated geometry for just that chain. Now, because we went through the trouble of selecting a particular contour, we're not going to bother with choosing a box for this option. It's always going to be the silhouette of that chain. So that's going to cover all of our operations for defining our geometry based off of the part itself. But if we do have our stock present in our CAM project, we can also go based off of the stock model as well. So if we exit out of this and we go back to our geometry option, we can see that we can also choose a stock-based boundary. What the stock-based boundary is going to do is it's going to actually look at what we've defined as our stock, and it's going to look at where the top of our actual part is and see what material is available between those two planes. And that's all the material it's going to know to remove. Now, the powerful thing about this is that it's fully stock aware throughout the entire CAM tree. So if we had some operations before this facing operation that, say, hollowed out the inside of this part and left just a thin lip around the edge, it would be fully aware of that, and it would know that it only needs to clean up the outside profile of the part. It knows that all the material on the inside has already been removed. So not only is this a quicker way of doing your initial setup because there's just fewer clicks involved, but it's a more powerful tool that's going to be aware of that stock throughout the entire CAM tree. So with our geometry selected, we can move on to our tool selection. Now, we're not going to cover the actual setup of the toolkits in this video. That's going to be a whole separate deep dive. So for now, we're just going to choose this little 2-inch face mill that I have here. And as you can see, we don't actually care whether you're using a true shell mill, a bullnose end mill, a normal end mill, or a taper mill for whatever reason. Whatever tool you'd like to use, you're able to use in this toolpath. With our tool selected, under the Data tab, we have all of our speeds and feeds. And under the Coolant tab, if you have flood coolant, MQL, mist coolant, this is where you'll be able to tick those boxes to enable them within your post processor. But an important note here, these will only be available based off of how your post processor is set up, so make sure that you have that set up correctly with your SolidCAM reseller. Next up is going to be the Levels tab. This is where we can define the various heights of our operation. Now, an important note here, just like the rest of SolidCAM, there are ways of doing this associatively, where it's going to be permanently tied to the model geometry itself, or unassociatively, where it's essentially a hard-coded value. The way we differentiate between that is whether the box has a green shading to it or this normal white shading. The green shading indicates that it is associatively linked to the actual geometry in the model. For example, this top milling levels here, we see the upper level is currently set to by top of stock. So that is associatively linked to the actual top of what we've defined as our stock model. Now we can change that with a couple other dropdowns. It could be top of target or user defined. And we can also just manually enter values in here as well. Now an important note, if I were to just manually type say 0.05 in here and click off, you can see the box is now white. This is essentially a hard-coded value. It will always be this exact number. But if instead of doing that, I click in the box and I select geometry, in this case the top of my stock, you'll see that that now automatically defines it as green, and it is now physically linked to the top surface of my stock. SolidCAM also changes this field to user defined just to let me know that I have physically hard-coded this value in here and that it's not from one of the preset dropdowns anymore. Now we're just going to change this back to what makes a little more sense. We'll set this to the top of the stock, and we'll leave everything else default for now. This is also where we can define our step downs. So if you wanted to set a maximum step down because you know you have a fair bit of material, you can do that here. And if you'd like, if you know that you're going to potentially have some remainder left over where you're taking like a 2 thou cleanup pass right at the very end, you can instead tick this box to make it an equal step down. And this will divide everything out as evenly as it can, using this as a maximum value. So you don't end up with just a couple thou cleanup pass that kind of wastes an extra pass. Next is going to be our Technology tab. This is where we actually define the functionality of the toolpath itself. This first dropdown, Technology, will define the actual type of toolpath that we're generating. In this case, we have hatch, contour, one pass, and spiral. And then you can further refine the details of that toolpath in this page and the subsequent tabs up top. In the case of hatch, this is going to be a relatively straightforward toolpath where we're just zigzagging back and forth across the part, and we can see a little preview of that here in the bottom left-hand corner. The first thing we can define is our minimum overlap. This is essentially the inverse of your step over. You're telling it what percentage of the tool diameter you'd like to overlap with subsequent passes. You can have this be a percentage of the tool diameter or a hard-coded value, and change it for whatever makes sense for your particular tooling setup. For depth cutting type, we have the options of one-way and zigzag, and this is essentially defining how we want to handle multiple passes at multiple depths. Whether we want the tool to zigzag, i.e. where it finishes at one depth, it just goes right back into the cut, or one direction where it will actually come back up out of the cut and restart at the same starting location before continuing the next set of passes. For sort cutting order down here, complete Z level, this would be if you have a couple different islands on the part. You can either have the tool stay down and do one island at a time, then move over to the subsequent island, or if we click complete Z level, it'll do both islands at the same time. And lastly, if you wanted to add some extra offset material for a cleanup pass later, you can do so here, and you can even have us do the finish operation within the same operation by clicking the finish pass right here. Now you can further refine the actual hatch toolpath itself underneath the hatch tab. Now an important note here, these tabs will dynamically change based off of the technology selected. So in this case I have hatch and I have a hatch tab right here, but if I change this to contour, you'll see that this changes to contour, and the information in here as far as what I can change will also dynamically change. So if we go back to technology, change this back to hatch, we'll see that we have the hatch specific parameters. Now let me generate some default toolpath here so that we can see what we're talking about with all of these various changes. The first thing we have is the hatch angle, and this is defining what angle to place this toolpath at on top of your part. Now by default, an absolute angle of 0 is going to be in the positive X direction, so you can see that we're going across the part in the positive X direction. Now you can change this to whatever you'd like, or you can have SolidCAM calculate the optimal angle based off of part geometry. And what we're doing in the back end is just looking at what will give you the longest continuous line for your toolpath direction. So if you have a weirdly shaped part or it's at a weird askew angle in your machine, we can automatically calculate that for you. Next up is going to be cutting direction. So we can choose either one way or zigzag. Zigzag is what we have currently, where it's traveling back and forth left and right across the part, and one direction will force it to only go, say, left to right across the part. For starting point, we're essentially defining what corner of the stock we'd like to start our operation on. So if I wanted to say switch it from starting in the top left-hand corner here to the bottom right-hand corner here, I can simply click this corner down here, recalculate the toolpath, and we'll see that it's now switched to the bottom right-hand corner. Now for extensions, we have two different options. We can choose to add extra toolpath on the, say, left and right side of the toolpath, or in the top and bottom of the toolpath that we see here. For along, that's going to be in the cutting direction, so in this case it's going to be in the X-axis. And for across, that's going to be in your Y-axis, so across the width of the part in this direction here. These can be coded as either a percentage of your tool diameter or a hard-coded value. Now for corner, it'll make a little more sense if I change the cutting direction back to zigzag. So let me change back to zigzag and recalculate that for you. And this is essentially going to change whether we're making sharp 90s when we go back and forth across the part, or if we add a bit of a fillet to it. So if I change this corner, currently it's set to none, to a fillet, and I click recalculate, you'll see that it's going to round off these corners for me, which on some machines will be a little bit nicer to their machine frames. And lastly, if you'd like, you could add a roll-in as well. That just helps for a more gentle ingress into the part. That's it for hatch. Let's take a look at some of our other technologies. Next one that we have is contour. So this is going to essentially take the outside contour of your part and step that in little by little, depending on your overlap, until you reach all of your part. Now you'll notice, because we've changed to contour, that our options for what we can change also change. So if you look at the technology tab, there are certain values that are now grayed out because they're not really applicable to this particular toolpath. Let me generate this toolpath here so you can get a preview of what that would look like. This first option here, corner, is going to define how we handle these sharp 90s that we come into. By default, it's set to none, but we could change that to something like a fillet and kind of round those corners off a little more nicely. We also have the options of loop and sharp, and this just helps to eliminate any cusping that you may get in these corners depending on your toolpath and your part geometry. You can define your cutting direction, climb or conventional cutting. You can also define the transition from one contour into the next. Currently it's set to linear, so it's just going to make a straight pass into that next contour, or we can have it be smooth where it just kind of warbles a little bit out of plane here. And lastly, we have extension, the same as the other toolpaths. Our next technology we can choose from here is going to be one pass. Now this is going to be a little more niche. This would be if you're using a shell mill that's large enough that you can machine the entire top surface of your part in a single pass. It's probably the simplest toolpath to set up, but obviously isn't always going to be applicable. By default, SolidCAM is going to calculate the geometric center of the part so that theoretically if that shell mill is big enough, it'll clean up the entire part in a single pass. Obviously, if the part was askew at a weird angle or the part itself was just oddly shaped, you may need to change the angle of attack for that tool. And that's where that automatic optimal angle calculation can really come in handy. And lastly, on the technology side, we also have our spiral toolpath. Really not too much to change here. We have our roll-in options, which are already preset, and of course we can change what our overlap is for our tool. Next up, we have our linking operations. Here we can change in our lead in and lead out for our toolpath, just based off of our preferences and what might be best for our tooling and our particular setup. And that's going to cover it for our video on facing operations for milling parts. If you guys have any questions at all, feel free to reach out to the help information in the description of this video, or to leave a comment directly on the video itself. Thanks again for watching, and we'll see you in the next one.